Deep beneath the rolling hills and historic towns of Massachusetts, something extraordinary is unfolding. Something that has remained hidden for eons, far beyond the reach of ordinary life above. It's not the familiar rumble of the T subway, nor the echoes of revolutionary footsteps on cobblestone streets. What's happening is far older, far more intense, and far more mysterious than anything in the state's storied past. For generations, scientists believed New England's geology was stable, even uneventful, a landscape shaped by ancient glaciers and time, not by fire or upheaval. But a recent scientific breakthrough has shattered that assumption. Researchers have uncovered a fiery secret, buried miles beneath the surface, that is rewriting the geological story of the region. Picture yourself strolling through Boston Common, the city bustling around you, completely unaware of the powerful drama playing out deep below your feet. Teams of geologists from MIT and Woods Hole set out to map the ancient rocks beneath Massachusetts, expecting to confirm the region's reputation for cold, unchanging stone. But as their seismic instruments probed the depths, they detected something astonishing, a massive anomaly, a signal so strong and unexpected that it defied all previous understanding. This was no minor blip or technical error. It was a vast, undeniable feature in the Earth's mantle, stretching for miles and glowing with heat. The scientific community was stunned. It was as if someone had discovered a hidden, molten chamber in the basement of your own home, a secret room pulsing with energy, right beneath your feet. Suddenly, all the old theories about New England's quiet, uneventful geology were thrown into doubt. Researchers began to question what else might be lurking beneath the surface, waiting to be discovered. After months of careful analysis and repeated verification, the evidence was undeniable. A vast upwelling of hot material is rising from deep within the mantle, centered directly under western Massachusetts and the Berkshires. This isn't just a slightly warmer patch of Earth. It's a significant thermal anomaly, a plume of heat that has been quietly shaping the region's geology for millions of years, influencing everything from earthquakes to the landscape itself. Above ground, life continues as usual in peaceful towns and scenic hills, but beneath that calm exterior, a spectacular geological secret is at work, hidden from view but impossible to ignore. This discovery reminds us that our world is far more dynamic, mysterious, and alive than we often realize. Even in places we think we know well, the Earth holds secrets that can change everything. And now New England, long considered geologically quiet, finds itself at the very center of a groundbreaking scientific revelation, with the ground beneath our feet holding stories yet to be told. So what did scientists actually find? After years of research, seismic surveys, and computer modeling, the answer turned out to be far more dramatic than anyone expected. Deep beneath the surface, they discovered a massive, slow-moving blob of intensely hot, partially molten rock rising from the mantle, a phenomenon known as a mantle plume. Imagine a giant slow-motion lava lamp hidden 120 miles below your feet. This upwelling of heat and rock is like a colossal column pushing upward through the solid crust right beneath New England. But don't expect a volcano to suddenly erupt in your backyard. This is a process that unfolds over millions of years, gradually altering the landscape in ways that are almost imperceptible in a human lifetime. What's truly astonishing is the location, New England, a region considered geologically quiet, far from any tectonic plate boundary or known hotspot. Finding this upwelling here is like stumbling upon a polar bear in the Sahara Desert. It completely defies what scientists thought they knew about Earth's deep processes. The hot rock itself is a slushy, dynamic mix of crystals and magma, hundreds of degrees hotter than the surrounding mantle. It's a churning, glowing mass, slowly making its way upward. Over immense spans of time, this heat acts like a blowtorch, thinning and weakening the plate above. The result? Subtle shifts in the landscape, gentle uplifts, and changes that only become obvious over millions of years. The sheer scale is staggering. This underground mountain of heat stretches for hundreds of miles, dwarfing anything on the surface. It's a powerful reminder that even the most stable-seeming places are intimately connected to the restless, fiery heart of our planet. This discovery isn't just a scientific curiosity, it's a crucial piece of the puzzle for understanding how Earth's interior shapes the world we live on, and how ancient forces continue to mold the continents. For the scientists involved, the discovery is both humbling and awe-inspiring, a vivid reminder that our planet is alive, dynamic, and full of surprises still waiting to be uncovered. How do you see 120 miles underground? Not by digging, but by listening. Scientists use seismic tomography, like a CT scan for the planet, tracking vibrations from earthquakes worldwide. Hundreds of seismometers, part of the EarthScope project, recorded how seismic waves traveled through the Earth. Waves move faster through cold rock, slower through hot, less dense rock. By mapping these speed changes, scientists built a 3D image of the mantle. Under New England, waves consistently slowed in a specific region, a clear sign of something hot and unusual. Supercomputers ran models to match real data, revealing the size and shape of the anomaly. The result, a detailed high-resolution map of a hidden molten upwelling. This breakthrough combined fieldwork, global data, and immense computing power. It's a triumph of modern geoscience, and it's changed our view of what lies beneath our feet. This discovery isn't just about today, it's a window into Earth's deep past. The magma plume story begins with Pangaea, the ancient supercontinent. New England was once at the heart of a massive continental collision, forming the Appalachian Mountains. When Pangaea broke apart, heat from the mantle drove the continents away, creating the Atlantic Ocean. Scientists thought that heat source had long cooled, but this plume is a lingering ember from that ancient event. It may be a remnant of the great meteor hotspot, once thought extinct. This connection gives us a living laboratory to study how continents break and oceans form. The hot rock beneath Massachusetts links us directly to one of Earth's most dramatic chapters. It's a reminder that the past is still alive deep below. To really understand this fascinating discovery, let's break down what a mantle plume actually is and why it matters for our planet's geology. Earth is built like a giant layer cake, a thin, brittle crust on the outside, a thick, slowly flowing mantle beneath, and a blazing hot core at the center. Each layer plays a unique role in shaping the planet's surface and its dynamic processes. Deep inside, heat from the core rises up through the mantle in swirling convection currents, much like water boiling in a pot on your stove. These currents are constantly moving, driving the movement of continents and the creation of mountains and ocean basins over millions of years. Sometimes, this heat doesn't just rise evenly. Instead, it forms a focused, narrow column of extra-hot rock called a mantle plume. These plumes can originate from as deep as the boundary between the core and the mantle, traveling thousands of kilometers upward. When a plume reaches the base of the crust, it spreads out, melting rock and creating vast reservoirs of magma. This process can fuel some of the most dramatic volcanic eruptions on Earth. If the plume is strong enough to break through the crust, you get volcanoes like the ones in Hawaii. There, the Pacific plate slowly drifts over a stationary plume, creating a chain of volcanic islands that rise from the ocean floor. But the plume beneath Massachusetts is different. It's weaker, less focused, and unable to punch through the thick, ancient North American plate. Instead of erupting, its energy is trapped below the surface. Rather than creating volcanoes, this hidden plume gently heats and swells the plate from below, causing the land to rise ever so slightly over time. The effect is subtle, but it's enough to reshape the landscape. This slow, persistent uplift may help explain why New England's terrain sits higher than other old, stable continental regions around the world, even though it lacks active volcanoes or major earthquakes. It's a quieter but still powerful expression of Earth's inner heat, one that doesn't make headlines with eruptions but still shapes the land in profound ways. The planet's inner plumbing is far more complex and more surprising than we ever imagined. Mantle plumes are just one part of a vast hidden network that moves heat and rock around the globe. Even in places that seem quiet on the surface, the mantle's energy is always at work, slowly but surely shaping the world above. And sometimes, if you look closely, you'll find the clues to this hidden activity right beneath your feet, waiting to be discovered by the next curious mind. The EarthScope transportable array was key to this discovery. Over 400 portable seismometers were deployed across the US, listening for years to the planet's faintest rumbles. These sensitive instruments captured vibrations from local trucks to distant earthquakes. The data collected was massive, over 1 million gigabytes. Supercomputers then processed this data, running complex models to reconstruct the mantle's structure. The result? A high-definition 3D map of what lies beneath North America. This blend of technology and teamwork is revolutionizing our understanding of the deep Earth. We're finally seeing the hidden world below with unprecedented clarity. Molten rock under Massachusetts sounds alarming, but there's no need to worry. The plume is deep, slow, and not about to erupt. These are changes on a million-year timescale. However, it helps explain New England's occasional small earthquakes and its higher-than-expected elevation. The hot mantle weakens the crust, allowing stress to release along ancient faults. The region's subtle uplift is likely caused by buoyant hot rock pushing up from below. For residents, this is less about risk and more about understanding our dynamic planet. The ground beneath us is alive, shaped by forces we're only beginning to grasp. This discovery adds a dramatic new chapter to New England's story. It's a reminder that even the most familiar places are full of hidden wonders. This discovery has global implications, not just local ones. It challenges our ideas about where mantle plumes can exist and how continents behave. If New England hides such a feature, other boring regions might too. This could spark new research into the deep earth across the globe. Understanding these processes helps us find resources and predict geological changes. The movement of heat and rock in the mantle drives everything from mountains to earthquakes. Studying the New England plume sharpens our picture of Earth's engine. Every new discovery brings us closer to understanding our planet as a whole. The hot river beneath Massachusetts is a perfect example of science's thrill. It's about curiosity, technology, and the joy of the unexpected. There are still mysteries to solve, sometimes right under our feet. Science pushes us to question, explore, and expand our knowledge. The ground we walk on is shaped by epic, unseen forces. Every discovery connects us to Earth's incredible history. As long as we stay curious and support science, there will always be new wonders to uncover. The adventure is just beginning.